Hey guys, this is Kerbal Space Program. So the mission is I have an asteroid that I'm tracking in my solar system, and I know that it's going to intercept pretty close to the Earth, pretty low orbit. So it'll be going really fast, but I think that I'm going to be able to catch up with it, and hopefully, let me zoom in here. Alright, so hopefully I will be able to get all of this right here in space. So this top part will land on the actual asteroid, and then this will remain in orbit until this comes off of the asteroid, docks with it, and then it'll depart its little astronaut back in here, and then this will return to Earth with all the scientific data and whatever. So yeah, basically, you'll see it when it happens. It'll be pretty neato. But I'll show you this over here. So this is a list of all the stages. We have the first couple of engines. Let me zoom out again so you can actually see what the actual rocket looks like altogether. Get rid of that. Alright, there we go. So that's what the entire rocket looks like. I can kind of spin around it. So we have what's called solid fuel rocket boosters. So as soon as I turn them on, I cannot turn them off. There's no throttle of the fuel. I can't limit how much power they're outputting. Those ones will output. Let me check how many newtons they output. Those ones output 1,700 kilonewtons, and then this one will output 2,000 kilonewtons. And then I have another engine in here, which is the Skipper liquid fuel engine, and that one is, where is that one? That one is right over here, and that one has 650 kilonewtons, but it doesn't need that much strength as long as it's super efficient because it's going to be in space. And when you're not fighting against gravity anymore, it's really easy to increase your momentum and your velocity. So then I have these three engines here at the bottom, and then I have all of these, which are really just the little engines right there that are glowing green right now. So when I turn those on, it'll make it so that then these giant rocket silos will go away from the ship. That way they don't crash into each other. And then this is like all the staging. So first this will happen. So first these three engines will light, and then these engines will light, and it'll decouple those engines from there. And then this engine will light, and then this engine will light after it decouples, and then this entire thing will explode, and this will come out, and we'll put this into orbit. So yeah, I'll just do that all in front of you, so that then you can actually see it in the workings. It'll take a while to load. Do 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 do. Do 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 do. Alright, so now we are on the launch pad, and I have fins on it just so it's more stable. So we'll go ahead and wait a second. Launch. So, after we get going fast enough, because these two solid rocket boosters don't have enough thrust to weight ratio, but as soon as we get going fast enough, we're gonna start leaning to the right a little bit over here. We're basically gonna go about 30 degrees to the right. That way, we are going prograde in the same direction that the Earth is rotating, which will give us a little boost for kilometers. I think it's like I think it's like 1 kilometer in a second of boost that we get, but that's a really decent amount. So, yep, we're gonna do that. All right, let's look at our trajectories. Alright. Alright, let's start turning now. So to get into space, you need to go straight up, but to stay in space, you need to get into orbit, and to do that, you need to go really, really fast, perpendicular to the planet's surface. So that's why I'm starting to turn a little bit. So by the way, I have been flying this entire time. Normally I fly it with like 2 hands, one on the mouse and one on the keyboard, but I have been switching hands continuously with the phone so that then I can still control this with one hand. It's a lot harder than normal. Alrighty then. So our solid fuel is about to cut out. There it goes, and then we'll decouple that. And as you can see, the thrusters are working just like I thought they would, and they're pushing it away from it so it doesn't crash into it. And we're going to point that prograde as much as we can anyways. Look at where our apoapsis is. We're at 180, so we're going to have to burn a little bit prograde. It's fine, it's fine.
Get 2 sausage McMuffin with egg sandwiches for just $4 at McDonald's. Ba-da-ba-ba-ba. Visible is a $40 a month all-in phone service on Verizon's 4G LTE network. I'm sorry, is the camera not getting a little close? No? Anyway, you need to get unlimited browsing. Browsing. Is this whole unlimited browsing concept just a play on my eyebrows? Come on! Visit unlimitedeyebrowsing.com.
So
Visible. $40 a month.
now I'm going to burn prograde, which basically just means that I'm burning in the same direction that I'm already accelerating. That way I'm just increasing my velocity in that direction. That way I'm basically infinitely missing the Earth. That's how things get into orbit, is they're just infinitely missing the Earth. And then if we just do that,
Come build the skills that employers demand and programs they help design. Learn more at maryville.edu/info.
So I would tell you all the math that it takes to do this, except that would be pretty boring. So well, I mean, I guess I can. So basically, I need to know the gravity of the object that I am going to land on. That way I know how much I'm going to weigh, because I know how much mass my spacecraft has, but I don't know how much it's going to weigh on that body unless I know what the acceleration of gravity on that planet is going to be. Like on Earth, it's 10 meters per second squared, but on the asteroid, I'm pretty sure it came out to being like 1.5 meters per second squared, just because it's so small. So really, it doesn't take a whole lot. It doesn't take a very strong engine to slow me down enough that I'm not going to crash into the asteroid surface. So my and I'm actually going to decouple this real quick, but my lander is actually super heavy for a normal asteroid lander. But that's just because I also have decently strong engines to land on. So, anyways, we are deploying our solar panels here. Alrighty then. Sweet, sweet, sweet. In about 20 seconds, we're gonna start our engines again. Well, let's speed up time a bit here. There we go. Okay, let's start our engines right now. There we go. So now if we go into the orbital view, we can see that our predicted trajectory is actually slowly becoming wider. If we zoom out here, then we zoom in with the phone, and you can see that my trajectory actually goes all the way through the core of the planet. My trajectory is the blue line. So it actually goes all the way through the core of the planet. And that's saying basically if all of the mass of the Earth was centered at that point on the Earth, then that would be our orbit right now. If we just cut the engines, that would be our orbit. But because that's not where the mass is, it's in reality the mass is much larger. That means that our trajectory will land us right back on Earth, and we'll crash into the Earth if we cut our engines right now. Decoupling my other piece there, so I'll zoom out here so you guys can see that better. Alright. Oh. There we go. Okay. So the lowest altitude of our orbit is called a periapsis, and it is at 148,000 meters right now. And then our highest altitude of our orbit is at 186,710 meters right now. And then we're going to start tracking the asteroid, which is not actually this asteroid. It looks like we're tracking this asteroid, but really we're going to be tracking, where is it? Its name is like YST or something like, it's YRJ. That's what it is. Alright. So our asteroid, its lowest point is 86,000, which is actually crazy low. Like that could be like skimming the Earth's atmosphere basically, but whatever. I don't really care because this is not my planet. This is just a video game planet. No one lives on this planet. Let's see here. So now I'm going to add a maneuver so that then basically I'm going to burn in a direction that makes it so that then my orbit matches up with the asteroid's orbit. And in reality, the asteroid isn't actually orbiting, it's just that it's coming in at that like swooping angle. And I want to make sure that I am also along that angle so I can rendezvous with it. Basically, it's just really easy to manage everything, or it's just way easier to manage everything if we're working in a 2D plane rather than a 3D plane. So I'm just gonna turn off RCS real quick. Alright, cool. Cool. And then I'm gonna speed up time a bit.
came from me. Really, my first idea was in one quarter
All right.
your savings will tower.
Oh my gosh, I hate the ads in the background.
That's not catchy, is it?
I hope you guys can hear that.
So I thought, what about 15 minutes, 15%? Serendipity.
Geico. 15 minutes could save you 15% or more on car insurance.
This holiday, get the 5G America's been waiting for.
Verizon 5G is next level.
Unlimited plans start at just $35 with entertainment the whole family will love. Switch now and save $700 on Galaxy S20 Plus. Only on Verizon.
So those giant wing-looking things are literally just the solar panels. Alright, and we're decoupling that stage now. Gonna leave that behind, and we're using our xenon thrusters, which are actually super cool. So what they do is basically they're a microwave as an engine. So this this engine shoots electrons at a specific atom called xenon, which is also heavy in electrons. And when it shoots this atom with electrons, it makes it so that then that atom drops its other electrons and fires it out the back of the engine, and that causes propulsion. And because it's firing so many electrons, it's actually it's a really weak kind of propulsion. But if I do it for a sustained amount of time, then it eventually adds up in momentum. Because even though it is a small amount of acceleration, it eventually adds up to a lot of acceleration over time. It takes a lot of electricity to use, and that's exactly why I have these solar panels. By the way, that engine is real. It's used all the time. All the engines and all the parts in this game are real. Even these ginormous solar panels. Alright. Just gonna do a couple more burns. Alright, cool. So I'm gonna end this video here, get into orbit, and get into rendezvous with the asteroid, and then I'll start another video. And it'll be the video of me landing on the asteroid. Well, actually, it'll probably be the video of me getting into orbit of the asteroid and landing on the asteroid. So, bye.